Hello friends, welcome to this video on the topic learning from multiple representations. This is Shomir Roy, Professor of Computer Science and Engineering at National Institute of Technical Teachers Training and Research, Kolkata. The topic learning from multiple representations will be discussed in two videos. This is part 1. Here we will discuss the subtopics applications of clustering in educational data analytics, factor analysis and knowledge inference. After successful completion of this unit, you will be able to describe the principles and techniques of learning from multiple representations and initialize the process for applying the principles and techniques of learning from multiple representations in teaching learning. Let us start with applications of clustering in educational data analytics. In the context of educational data analytics, the aim of clustering is to discover the inherent grouping structure of educational data. This is helpful in enhancing the e-learning experience. Clustering is an unsupervised machine learning methodology where the goal is to assign each of n unlabeled data items to one of k possible clusters. In case of fuzzy or probabilistic clustering, a fuzzy membership value within the range 0 to 1 or a probability of cluster membership is returned. Clustering is done on the basis of some similarity measure among the data elements. If we consider the data as points in an n-dimensional hyperspace, then the similarity measures is Euclidean or Mahalanobis distance between the points. This figure shows the application of clustering as an effective educational data mining technique and related applications or activities. For the source of this figure, please see the e-contents. It starts with the analyst selecting the data set for analysis, then downloading the log files from the target e-learning environment. Subsequent phase depends on the event logs. Data cleaning is an important step where the data analyst removes the irrelevant components and retains only the essential parameters. Data cleaning is followed by data partitioning. Data partitioning refers to extraction and combination of relevant data for future analysis. The process of clustering for the purpose of creation of learners groups can be done after preparing manageable data sets. Clustering has been successfully applied on educational data on various occasions. Most of these belong to three main categories. 1. Those attempting to group similar e-learning materials together. 2. Those which try to group the learners on the basis of their navigational as well as learning behavior. And 3. Works that intend to apply clustering in developing e-learning strategy. Underlying the visible or measured variables, there exists latent variables or factors. Factor analysis reveals the structure of associations in terms of these factors or latent variables. In order to achieve this, factor analysis tries to identify the interrelated variables. It starts with the correlation matrix of bivariant associations among the observed variables. This matrix helps to identify the variables that are interrelated among themselves. Factor analysis tries to form clusters of strongly correlated variables. In other words, factor analysis looks for factors responsible for variations among the observed variables as much as possible. Factor analysis consists of a number of iterative steps. In the first step, an extraction method is applied to identify combinations of observed variables called factors. Popular extraction methods, among others, include principal component analysis and principal axis vector analysis. In the next step, the number of factors that adequately summarize the relationship between the original variables is decided. There are rules of thumbs to facilitate this step. Finally, psychological conclusions are drawn on the basis of factor loading and or interfactor correlations. The value of association between an observed variable and a factor is called factor loading. Factor loading are defined in terms of correlational metrics in the range of -1 to +1. Values close to 0 indicate weak or no association between a variable and a factor, while values close to -1 or +1 refers to strong association. Now we come to knowledge inference. There are two important knowledge inference techniques, namely the Q matrix and learning factor analysis. Q matrix is a matrix presenting the Boolean relationship among test items and related skills. Each row of a Q matrix corresponds to an item and each column a skill. The ith cell of the Q matrix contains 1 if item I requires skill j, otherwise it contains 0. Let us consider a Q matrix with m test items and n concepts or skills. Then a concept state is defined to be an n-bit binary string where the kth bit is 0 if the student does not have the concept or skill k. Otherwise, that is if he has the concept or skill, the said kth bit is 1. Obviously, there are 2 to the power k or 2 to the power n concept states. Corresponding to each concept state, there is an ideal response or IDR vector. The IDR is an m-bit binary string where the ith bit is 1 if it is possible to answer the ith question on the basis of known concepts or skills as indicated in the concept state C. With the help of IDR, we can predict the answer a student in that state would give, provided there is no slip or guess by the student. Learning factor analysis or LFA is a semi-automated method for generating a cognitive model of a student. It is a combination of statistical model, human expertise, and state space search. The statistical method quantifies the skills. Human expertise is expressed as the difficulty factors that may affect the student's performance, and state space search is used to select the model. Performance of a cognitive model is often measured by how well the data fit the model. A power relationship between the rate of error in performance and the amount of practice is given in the equation y is equal to a x to the power b. Here y is the error rate, x is the amount of practice in terms of number of times the skill has been practiced, a is the intrinsic difficulty of a skill, that is error rate on the first attempt, and b is the learning rate, indicating the ease of learning a skill. The curve for the relation is known as the learning curve. Our next concern is the difficulty factors. A difficulty factor is that aspect of a problem that causes difficulties to a learner. Given a pair of problems that differ in a single factor, it is possible to assess their performance difference. This leads to discovering hidden knowledge components that help to improve the cognitive model. Finally, a state space search is employed to select the model from the model space of logistic regression. An operator called binary split is used to incorporate the difficulty factors into the existing cognitive model. This operator splits a skill into two, such as a skill with a factor value and the other without it. A best fit search has been reported for this purpose. Starting with the initial goal, the search algorithm iteratively generates new nodes, explores these new nodes until it reaches the goal. Difficulty factors are included into the model through splits or adds. A heuristic based on Bayesian information criterion (BIC) is employed to rank the nodes. The nodes are explored in the order of these ranks. This figure shows the partial search tree. The source of this figure is given in the e-content. So my friends, we have come to the end of the first part of 2 videos on the topic learning from multiple representations. I hope you have enjoyed the lesson. For further details, please see the e-contents of this lesson. Thank you very much and see you again in the next video where we will discuss the remaining parts of this topic. Have a good day.